Video we'll be learning about how to complete the square for quadratic equations and what does it actually tell us once you completed the square. Alright, so let's see this with an example. First of all, you should understand that the same quadratic equations that we had before can be written in factorized form or as a completed square. We know I've worked backwards and I'm already showing you the shape of the graph here because when you want to factorize it, you'll figure out that the roots of this equation are actually -3 and -1 because in a factorized form these are there. All right, but here we're going to learn a new skill, and first of all I'm showing you why is it important to understand the completing the square. After you completed the square, the final answer will help you to figure out what's this minimum point or the coordinate of the minimum point of the graph. Is this minimum point is also called the turning point, and in some graphs it may be that you have a equation like so and it will have a maximum. I apologize about my drawing, it's not perfectly symmetrical, but quadratic equations are in fact always symmetrical about this point, about this axis here. And that point, the turning point, is where the graph is symmetric. Alright, so let's see how to complete this square. In a nutshell, you always look out for the coefficient of x here, that is this 4. You divide that by 2, so 4 divided by 2 is a 2. You write it as so here. Now I'll show you in more detail why we do this. And finally, this minus sign is always there, and that's this 2 that's squared here. I'll show you in geometric terms how this comes about. But notice that after you combine this 3 with a -4, you end up with a -1. So this -1 is telling us that the turning point has a y value of -1. And this bracket here, when you set it equal to 0 and you solve it, what you get is x equals to -2. That tells you that the x value here, as is already shown, has the turning point of this graph has x value of -2 and y value of -1. -1 coming from here. Alright, so now I'll show you in more detail how you complete the square. Uh, the one actually did complete the square because this equals to 0. You can go ahead further and solve it for the roots of x as well, the roots of the graph. You can take 1 to the other side, take the square root of 1, which is plus or minus 1, and then take away 2 from both sides. So one of the equations, one of the roots 1 and the other root would be -3. Of course, this is a longer way of finding the roots than just factorizing. I would prefer just to get to this line here and factorize this equation to figure out the roots. But if you had to solve it, this is the process you would go through. Now let's look at just completing the square and how we end up with these first few operations that you may have already forgotten. Don't worry, I'll show you in the next slide. So when you have, let's just say that we ignoring the fact that there is a plus c here, because that plus c uh, doesn't it won't help us to understand anything yet. We have x squared plus a coefficient times by x. This coefficient b here, we can divide it by 2. Why? Because once I divide in a perfectly symmetrical shape, the x square is a square already. Notice, is a square. So its height and length are exactly the same. So that's its height and that's its length. Because this height is the same as the the height of this rectangle here. When I divide b by 2, I can put b like so on the sides of the square line, square. But we don't have this red square that's appearing there. So that's why we need to subtract that away. Notice the area of this red square is b over 2, because the length here we divide by 2 is now over here as well. So because this b over 2 is multiplied by b over 2, we have b over 2 square. Now we need to subtract that. So I'll show you with this example here, x squared plus 8. So if we want to complete the square here, we can divide this 8 by 2. So we write a plus 4, and now we put a bracket around it and we put the square on top of the bracket. This, notice, is a square. Okay, we did complete a square, right, from this rectangle here. This rectangle, which was a combination of a smaller square and a rectangle, is now in a completed square. Notice that we need to subtract something here. That something is 8 divided by 2 squared. Now 8 divided by 2 is 4, so we need to subtract 4 squared. So x plus 4 inside the bracket. This is completed the square form of this line here. So these two lines are exactly the same. That's x squared plus 8x. Alright, so we'll go through this process one more time and you'll notice what happened. Now let's say we did have a c here. We did have a c. What would this c do is that then we combine this value of a constant with a negative 16. Alright, notice no matter whether we have a plus sign or a minus sign here in the middle, you always subtract. Alright, so let's make a note here. We always subtract. Whether this is a plus or a minus sign here. In some cases, this may be a minus sign, but we always subtract the square this term here. Okay, because we didn't have this red square to start with, no matter what. Alright, so let's look at another example. Now, in this case, we have x squared minus 4x. So the geometry is there to help you, but in either case, you take this negative 4, as I said, is minus, so I divide it by 2, and I end up with a minus 2 here. So I'm going to put the square sign on top of that, and I still need to subtract because I don't have this, we didn't have this red square in this original shape, right? This original shape didn't have a red square. So we need to subtract a square of the 2. So the square of the 2 is a 4. So finally we end up with, well, I could have written 2 square here, and then on the next line I would have x minus 2 squared minus 4. So that's this completed the square form of x squared minus 4x. Now, what does that really tell us is that if we had to plot the graph here, the value of turning point, this point here, would have been x equals to 2 and y equals to minus 4. So the coordinate would be as such for the turning point. And that, furthermore, it tells us that the line of symmetry for this graph is x equals to 2. Let's look at another example. Now, in this next example, down here, we have a plus 12x. So we write x, what's half of 12? Half of 12 is a 6. So we write x plus 6 and we put the square sign here. We need to subtract something. That something is this 6 squared. So we end up with x plus 6 minus 36. What does this tell us? This tells us that the turning point of the graph is x equals to minus 6 and y equals to negative 36. So minus 6 minus 36 is the turning point of the graph. Alright, so let's look at another example. In this case, we have x squared minus 2x. So we half this coefficient of x, which is minus 2, half of that would be a minus 1, and we subtract 1 square. 1 square is 1. So in this next case, there is a coefficient in front of x squared. So there is an extra step that you must perform in this case at the beginning. Make note of it and don't forget about it. This extra step is at the beginning. This is what most students find very hard, is the fact that first you do have to factorize or divide by 2. If 16 wouldn't divide by 2, you couldn't factorize a 2 out of 16. You would perform a division. So in our case, the 2 does factorize both terms. So we get this expression here. 16 turns into an 8. And then we actually complete the square inside this bracket and leave the 2 outside. So when you want to do that, that means that completing the square inside the bracket here will have half of 8 would have been a 4, and then this 4 square gives us 16, which we always subtract. Now, most of the students forget about this red square bracket that I'm putting here and leave 16 as it is. What they do is they write 2 in front of the very first bracket and forget about multiplying negative 16 by 2. That's the most common mistake, and I hope you don't make that mistake. The correct answer is to finally multiply the 2 outside the bracket by every term. So you end up with negative 32 rather than just minus 16. Alright, so pause the video and try to complete the square on this question and then have a go at it with me. Alright, I hope you've had a go at it and then I'll show you the answer. So here, first we half the value of 4, we will get a 2. So we write x plus 2 and we put it inside the square bracket. We need to subtract 2 square. And also this minus 3 remains where it is. You just leave it there. Now you can write x plus 2 inside the bracket, the square bracket. Minus 4 minus 3 is a minus 7. So this is a square form. This tells us that the minimum point, the turning point of the graph is x equals to minus 2 because of this bracket, and y value is minus 7. Now, if we had to solve this equation, we would have taken 7 to the other side. We would have had x plus 2 squared equals to positive 7. Then you could take the square root of both sides. You end up with plus and minus root 7, and you subtract 2. So you end up with minus 2 plus 7 as one of plus root 7, and the other answer, I'm going to use a subscript here to indicate that there are two possible answers, minus 2 minus root 7. So those are the coordinates that it would cut the x-axis, where the graph would cut the x-axis. Alright, so let's look at the next example. In this example, we've been given x squared minus 6x plus 4, and we've been asked to complete the square. So, completing the square means halving this minus 6, put it in there, and then squaring a 3 is 9. I know you think a square of 3 is a positive 9. Why are we subtracting it? This is always the case. No matter whether you have a plus sign or a minus sign here, I said at the beginning, this will always be minus. Always. sign. So then we have a 4. Don't forget to bring the 4 down and combine -4 with a positive, -9 with a positive 4. So that will give us a -5. And then if when we have to solve this equation, we take 5 to the side, take the square root of 5, and then add 3 to both sides. So you end up with two answers. These two decimal points are where the graph will cut the x-axis. Alright, so I suggest you pause the video, think carefully about these two problems, have a go at them, complete the square. The question asks us to find the turning point by completing the square, and hence draw the equation, draw the graph for each of these equations. That involves you solving it as well as completing the square. So have a go at it, and then I'll show you the answer. Pause the video. Alright, I hope you've had a go at these questions. Now you've been playing this. What you notice is that the equation on the left here has a common factor of 3 as each of the coefficients here divide by 3. So you could simply factorize the 3 out of all terms. And at this stage, you could divide by 3. So you would say, well, but let's not divide by 3 and leave the 3 outside the square bracket here. So what you have is that you're dividing this -4 by 2 and you're putting it inside the bracket here. Then you have an 2 square, which is this 4 here. So this is 2 square, and this 3 is this 3 outside of the bracket here. So the red 3 is there. So that's why you end up with -12 -63. You leave the 63 as it is. Alright, then -12 -63 will give you -75. So if you do have to solve it, don't forget that this blue box here will tell you the coordinate of the turning point is x equals to +2 and y equals to -75. And once you solve it, you end up with two answers. X1 is 7 and X2 is -3 because 2 minus 5 is -3. So the reason I've put this blue box there is just to ensure that you know where the completed form is. This line is where the completed square form is. The completed square form told us that value of x is 2 and its y value is -75. Now the roots of the equation are 7 on the right and -3 on the left. Alright. If you had to figure out the y-intercept at this line here, you substitute x equal to 0 and you end up with 3 times -2 square -75. So substituting 0 will cancel away the 0, the x here. So 3 times -4 is -12. -12 -75 is -87. Therefore, this point here would have been a, sorry, my bad. This would have been a plus, this is 2 square is 4, 4 times 3 is plus 12, and 12 minus 75 give us -63. So the x-intercept is -63. I realize that because the minimum point of y value is -75 and we cannot go any lower than that. Alright, so the y-intercept is -63. Alright, so in the next question, the 50 wouldn't have divided by 3 anyway. We only factorize the 3 out of these two terms here, and we leave 50 as it is. Alright, So then we divide minus 4 by 2 and we write it like so, not forgetting that this 3 needs to be multiplied by minus 4. So the next line would give us minus 12 here, minus 12 minus 50 will give us minus 62. Now I'll put this in the blue box again because this tells us the turning point is where x equals to positive 2 and y equals to minus 62. Now we can go ahead and solve it for x with actually two answers. One of the x values will be 546 and the other x value will be minus 2 point, well, what is 2 minus 4.5? Is minus 2.546. Alright, so this tells us that if we have to plot the graph, always the right root is 6.546, the left root is at minus 2.546. The minimum point, notice, is symmetric around 2, so 2 comma minus 62, and the y-intercept uh, is found by substituting 0 into this equation here. So when x is 0, y will be minus 50. I didn't know why I didn't do that earlier here. I could have substituted 0 in this line here, and the y-intercept would have been 63. I could have read it from there. Alright, so I hope you found this video helpful. I'll see you in the next video.